In 1957, a mechanic from Daytona Beach made a discovery that would embarrass every major engine manufacturer in America. He found that the big, slow, agricultural engines powering farm tractors could be modified to produce streetcar power, and not just a little power, serious, highway-capable, get-out-of-my-way horsepower. His name was Henry Yunick, though everyone called him Smokey. And what he proved, that agricultural engines had hidden potential that manufacturers had completely overlooked, would change the way people thought about internal combustion forever. Along the way, we will encounter stubborn farmers, skeptical engineers, backyard ingenuity, and a man who simply refused to accept that things had to stay the way they were. So let us begin. But first, who exactly was Smokey Yunick, and how did a guy from a small Florida town end up teaching Detroit a lesson they would never forget? Henry Yunick was born on May 25, 1923, in Neshaminy, Pennsylvania. His parents were working-class people, and young Henry grew up understanding that if something was broken, you fixed it yourself. There was no money for repairmen, no budget for new parts. You made do, you improvised, you learned how things worked because you had no other choice. This upbringing would define everything that followed. By the time Henry was a teenager, he had already developed an almost supernatural feel for machinery. Engines, in particular, fascinated him. He could listen to a motor running and tell you exactly what was wrong with it. Timing off by 2 degrees, he would hear it. Carburetor running lean, he would know before you opened the hood. This was not a skill he learned in school. He barely finished formal education. This was instinct, refined through thousands of hours of hands-on experience. When World War II broke out, Henry enlisted in the Army Air Corps. He served as a crew member on B-17 bombers, flying combat missions over Europe. The experience did 2 things. First, it taught him how to stay calm under pressure. When you were being shot at by German anti-aircraft guns, you learned very quickly that panic does not solve problems. Second, it exposed him to aircraft engines, power plants that were engineered to squeeze every possible ounce of performance from every drop of fuel. This was efficiency born of necessity. A bomber that ran out of fuel over the Atlantic did not get a second chance. After the war, Henry Yunick drifted south, eventually settling in Daytona Beach, Florida. He opened a small garage called Smokey's Best Damn Garage in town. The name was not subtle, but neither was Smokey. He was blunt, opinionated, and absolutely convinced that he knew more about engines than anyone else on the planet. The thing is, he was usually right. Now, Daytona Beach in the late 1940s and early 1950s was becoming the center of American stock car racing. The beach itself served as a track, with cars roaring down the sand at speeds that would terrify most drivers today. Smokey saw an opportunity. He started preparing cars for local racers, and his reputation grew quickly. His cars were fast. More importantly, they were reliable. In racing, finishing the race is half the battle, and Smokey's machines almost always finished. By the mid-1950s, Smokey Yunick was one of the most respected mechanics in NASCAR. He had worked with manufacturers, he had built championship-winning cars, and he had developed a reputation for finding power where others saw nothing. He was, in many ways, the ultimate gearhead, a man who lived and breathed internal combustion. But here is the thing about Smokey. He was never satisfied with what the factories gave him. He looked at production engines and saw compromise everywhere. Manufacturers built engines for the average buyer, people who wanted reliability, fuel economy, and low maintenance. Performance was secondary. This drove Smokey absolutely crazy. He knew these engines could do more. He just had to figure out how to unlock it. And that brings us to 1957. See, by this point, Smokey had worked on just about every type of engine you could imagine. Racing engines, passenger car engines, truck engines. He understood the theory, but more importantly, he understood the practice. He knew what worked and what did not. Not because he read it in a book, but because he had tried it himself, failed, adjusted, and tried again. One day, Smokey found himself looking at a farm tractor engine. Now, farm tractor engines in the 1950s were a completely different breed from automotive power plants. They were designed for one thing: torque. Low-end pulling power torque that could drag a plow through heavy soil all day long without complaint. They ran at low RPMs. They sipped fuel slowly. They were built to last for decades with minimal maintenance. What they were not designed for was speed. A tractor engine did not need to rev high. It did not need quick throttle response. It did not need to propel a vehicle down a highway at 70 miles per hour. These were agricultural workhorses, not thoroughbreds. But Smokey saw something else. He noticed that these tractor engines had massive displacement, much larger than typical car engines of the era. They had robust bottom ends designed to handle enormous loads without failing. The crankshafts were heavy-duty. The connecting rods were thick. The blocks themselves were overbuilt, cast with extra material to ensure durability in the field. What if, Smokey wondered, you could take all that displacement and all that structural strength and redirect it? What if, instead of producing maximum torque at low RPMs, you could modify the engine to breathe better, rev higher, and produce power across a wider range? What if the agricultural slowness was not a fundamental limitation, but simply a design choice that could be changed? Now, this was not an obvious idea. The conventional wisdom at the time was that tractor engines and car engines were fundamentally different things. You did not modify a John Deere motor to power a Chevrolet. That was like trying to turn a draft horse into a racehorse. Different animals entirely. But Smokey Yunick had never been particularly interested in conventional wisdom. He started experimenting. He acquired a tractor engine. The specific make and model varies depending on which account you read, but the principles remained the same. He stripped it down to the bare block and began analyzing every component. The first thing he addressed was the cylinder head. Tractor heads were designed for low-speed operation, which meant the ports and combustion chambers were optimized for efficiency at low RPMs, not for flowing large volumes of air and fuel at higher speeds. Smokey modified the ports, reshaping them to improve airflow. He adjusted the valve timing to allow the engine to breathe better at higher RPMs. He increased the compression ratio, which had been kept deliberately low in the original tractor configuration, to improve fuel economy and reduce stress. Then he turned to the carburation. Tractor engines typically used simple, single-barrel carburetors that delivered fuel at a steady, measured rate. Smokey replaced this with a more sophisticated setup capable of delivering more fuel more quickly when the throttle was opened wide. The ignition system came next. Agricultural engines used basic ignition timing calibrated for low-speed operation. Smokey advanced the timing, optimizing it for higher RPMs. He also upgraded the ignition components themselves to handle the increased demands. Finally, he addressed the exhaust system. Tractor exhausts were designed to muffle noise in the field, not to evacuate spent gases quickly. Smokey opened up the exhaust path, reducing back pressure and allowing the engine to expel combustion byproducts more efficiently. Each modification was relatively straightforward on its own. Smokey was not inventing new technologies. He was applying established principles that every racing mechanic understood, to an engine that had never been intended for performance applications, and when he put it all together and started the engine, the results exceeded even his expectations. If you have made it this far, you are probably into this kind of stuff. Quick question: where are you watching from? Drop it in the comments. And hey, subscribe if you have not. We do this every week. All right, here is what Smokey discovered. The modified tractor engine produced power levels comparable to contemporary automotive V8s. Think about that for a moment. An agricultural motor designed to pull plows at walking speed was now generating enough horsepower to propel a car down a highway. The massive displacement that had been used for low RPM torque was now producing high RPM power. The overbuilt bottom end that had been designed to survive decades of fieldwork was now handling loads that would have destroyed a typical passenger car engine. But the really interesting part? The engine was actually more robust than a modified car motor would have been. Because it had been designed with such enormous margins for agricultural use, there was headroom that factory automotive engines simply did not have. You could push it harder, longer, and it would take the punishment without complaint. Smokey had essentially discovered that manufacturers had been leaving massive amounts of performance on the table, not because they could not extract it, but because they had never tried. The agricultural market wanted reliability and fuel economy. The automotive market wanted reliability and fuel economy. Nobody had bothered to ask what these engines could really do if you optimized them differently. Now, I should mention, Smokey Yunick was not the only person in America experimenting with engines during this period. The late 1950s were a golden age of hot rodding, and backyard mechanics across the country were modifying everything they could get their hands on. But Smokey's work with tractor engines stood out because it challenged a fundamental assumption. It proved that the line between different types of engines was more artificial than anyone had realized. The implications were significant. For one thing, it suggested that small farmers might have more options than they thought. If a tractor engine could be modified for automotive use, perhaps the reverse was also true. Perhaps there were cheaper, more flexible ways to power agricultural equipment than buying purpose-built tractor motors from major manufacturers. For another, it demonstrated that engine development had become stagnant. The big manufacturers had settled into comfortable grooves, producing engines that met market expectations without pushing boundaries. Smokey showed that there was still room for innovation, still unexplored territory in what was supposed to be mature technology. But perhaps most importantly, Smokey's work reinforced a philosophy that would define his entire career. He believed that the factory was not the final word. The engineers at Detroit might have designed an engine to perform at a certain level, but that did not mean the engine could not do more. The factory specifications were a starting point, not a ceiling. This philosophy would make Smokey Yunick both famous and notorious in the racing world. See, NASCAR in the 1950s and 1960s operated under rules that were supposed to keep competition close by limiting modifications. The idea was that teams would race essentially stock vehicles, with only minor changes permitted. This would prevent wealthy teams from outspending smaller operations and dominating the sport. Smokey viewed these rules as challenges to be overcome. His approach was simple. He would read the rule book very carefully, looking for loopholes. If the rules said you could not modify a certain component, he would find a different component that was not mentioned and modify that instead. If the rules specified maximum dimensions for one part, he would adjust related parts to compensate. He operated in the gray area between legal and illegal, always pushing the boundaries, always looking for an edge. The officials hated him. They would inspect his cars, find something questionable, and disqualify him. The next week, he would show up with something else they had not anticipated. It was a constant cat-and-mouse game, and Smokey seemed to enjoy it immensely. One famous story, and this may be apocryphal, but it captures his spirit perfectly, involves a NASCAR inspection where officials could not figure out how Smokey's car was producing so much power. They checked everything. The engine displacement was legal. The carburetor was legal. The ignition was legal. Everything appeared to be within specifications. Frustrated, they finally told Smokey he was disqualified anyway, based on general suspicion that something had to be wrong. Smokey reportedly got in his car, started the engine, and drove away from the inspection station without the fuel tank. He had hidden several gallons of extra fuel in the oversized frame rails. The inspectors had been so focused on the engine that they never thought to check the chassis. Whether this specific story is true or not, it illustrates the kind of thinker Smokey was. He did not just modify engines, he rethought entire systems. He questioned assumptions that everyone else took for granted, and he did it with a gleeful disregard for authority that made him a folk hero to some and a villain to others. His work with tractor engines fit this pattern perfectly. While other mechanics were focused on extracting marginal gains from automotive power plants, Smokey was asking a more fundamental question. Why limit yourself to automotive engines at all? If the goal was power, why not look at every possible source of that power? The agricultural engine modifications were never widely adopted, it should be said. The practical challenges were significant. Tractor engines were heavy, much heavier than car engines of similar output. They were designed for different cooling systems, different mounting configurations, different accessory drives. Adapting them for automotive use required extensive custom fabrication that was beyond the capabilities of most mechanics. But that was never really the point. Smokey's tractor engine experiments were proof of concept, not practical engineering. They demonstrated that conventional categories were misleading. They showed that performance potential existed in unexpected places. And they established Smokey Yunick as a man who thought differently from everyone else in the business. Over the following decades, Smokey continued to push boundaries. He worked with major manufacturers, including Chevrolet, helping them develop racing programs that dominated NASCAR. He built cars that won championships. He earned the respect of drivers, engineers, and fellow mechanics who recognized his genius even when they disagreed with his methods. He also became increasingly frustrated with the direction of the automotive industry. As emissions regulations tightened and fuel economy became a priority, Smokey saw manufacturers abandoning the kind of engineering creativity that had once defined the American automobile. Cars were becoming appliances designed by committees and constrained by bureaucrats. The wild innovation of the hot rod era was giving way to computerized conformity. In response, Smokey turned his attention to efficiency. He began developing engine designs that he claimed could dramatically improve fuel economy while maintaining or even increasing power output. His hot vapor engine, which used a sophisticated system to preheat fuel before combustion, was supposed to achieve extraordinary efficiency gains. Whether these claims would have held up to rigorous testing remains unclear. Smokey was not known for understatement when discussing his own work. But even in his later years, he remained the same man who had looked at a farm tractor engine and seen possibilities that everyone else had missed. He was still questioning assumptions, still challenging the experts, still convinced that he knew things the factories did not. Smokey Yunick died on May 9, 2001, at the age of 77. He had lived to see NASCAR transform from beach races to billion-dollar stadiums. He had watched the automotive industry go through revolution after revolution, fuel injection, computerized engine management, hybrid drivetrains, and beyond. Through all of it, he remained a mechanic at heart, a man who believed that the best way to understand something was to take it apart and rebuild it yourself. And what of his legacy? The specific techniques Smokey used to modify that tractor engine have been largely forgotten. No one today is converting agricultural motors for street use. The automotive and agricultural industries have diverged so completely that the exercise would be pointless. But the mindset he embodied, that is still very much alive. Every time a backyard builder looks at an engine and asks, "What if?" they are channeling Smokey Yunick. Every time someone takes a component from one application and adapts it for another, they are following his example. Every time an engineer questions whether the factory specifications represent true limits or merely comfortable assumptions, they are thinking the way Smokey thought. He proved that expertise does not require credentials. That innovation can come from a garage in Daytona Beach as easily as from a corporate research center. that the people closest to the actual work, the mechanics with grease under their fingernails, sometimes see things that the theorists miss. And he proved, perhaps most importantly, that agricultural engines could be modified to produce streetcar power. A fact that seemed impossible until someone actually did it. A fact that embarrassed the manufacturers who had spent decades assuming that their categories were fixed and their products were optimized. They were wrong. Smokey showed them they were wrong. And that, more than any trophy or championship, may have been his greatest satisfaction. Not bad for a guy who never finished school. And that is the story of Smokey Yunick and the hidden potential of farm tractor engines. If you enjoyed this one, subscribe for more and let me know in the comments. Had you heard of Smokey before this? Take care, and I will see you in the next one.